video we're going to describe what electromagnetic waves are and then list them in order of their frequencies and wavelengths. So electromagnetic waves are simply waves in which a field, an electric field as well as a magnetic field, oscillates perpendicularly, meaning at 90 degrees to the direction of wave travel. Now what that means is you've got an electric field as well as a magnetic field that oscillates at 90 degrees, which is perpendicular to the direction of wave travel. So for example, you might have an electric field that oscillates, which means a repeated rhythmic regular to and fro motion or change, variation of an electric field. So say for example, the electric field is going up and down at 90 degrees to the direction of wave travel. And you've also got a magnetic field which travels left and right to the direction of wave travel, right? So for example, what that means is a wave is directed towards you, right? So it's incoming towards you, you've got a wave that's traveling towards you. You've got an electric field that's oscillating up and down, which is at 90 degrees to the direction of travel. And you've also got a magnetic field which is traveling or oscillating left and right, which is again at 90 degrees to the direction of travel. So what that means is, in short, electromagnetic waves are transverse waves in which an electric field and a magnetic field oscillates at 90 degrees to the direction of wave travel. So we're going to list down the various components that make up the electromagnetic spectrum. A spectrum is simply a division of a thing into all of its different components. So in this case, because we're talking about the electromagnetic spectrum, what we're going to do is we're going to break up the electromagnetic spectrum or all electromagnetic waves into all of their various components. In fact, I'm going to list them down. The various electromagnetic waves that we see around us are radio waves, microwaves, infrared, visible light, ultraviolet, X-rays and gamma rays. So you can remember the order, the relative order of all of those different components that make up the electromagnetic spectrum using the first the first letters of all of those waves, right? So you can create an acronym out of them. I usually remember them as R, MIVX, G. R standing for radio waves, followed by microwaves, infrared, visible light, ultraviolet, X-rays and gamma rays. In the coming videos we're going to see some applications of each of these waves, but for the time being all you need to know is that as you go down the spectrum, meaning from radio waves all the way through to gamma rays, the frequency increases. So for example, microwaves have a higher frequency than radio waves, infrared have a higher frequency than both of the waves above, and so ultraviolet has a higher frequency than all of the waves above, and so on. So gamma rays have the highest frequency, and radio waves have the lowest frequency. And with that, the wavelength decreases as you go down the spectrum. So, for instance, microwaves have a smaller wavelength than radio waves. Infrared has a smaller wavelength compared to both radio waves and microwaves. And so gamma rays would have the smallest wavelength. So it's a pattern that you need to remember. Finally, all of these waves do follow the wave equation. So V is equal to F lambda. So the velocity or the speed at which the wave is traveling is equal to the frequency at which the wave or the oscillations of those electromagnetic fields are occurring, multiplied with the wavelength or the distance between the two crests or troughs or successive similar points, right? So with that, take care and bye.